Hello once again, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek into my personal experiences. This is a channel designed with you in mind. Let us dive into today's lesson. As we are continuing with our ultimate guide in organic chemistry, the next part that I want us to cover is the IUPAC naming of alkenes. We have already looked at the IUPAC naming of alkanes, and this is a continuation, so you need to grab hold of the previous lesson. Now let us look at how do you name alkenes. Now it is very important for you to follow also a few rules here, and I'm going to take you through the process. So let's look, for example, at the compound that is given here. And now whenever you're dealing with alkenes, remember you need to look at the functional group of alkenes and you need to identify that part, the carbon, double bond, carbon. So that is the key part that tells you that we are dealing with alkenes. Now the next thing is try to convert this structure into a what? Into a condensed structural formula. So if I can convert that, what do I have? I have CH3 and CH2 and then double bond, actually it's C, double bond C and that, and CH3. So this one is CH and also here it's CH. So it's 1, 2, 3, 4, 5. It's also 1, 2, 3, 4, 5. So this is the structure that I have. I can just mention this is 1, 2, 3, 4, 5. You see that? But now remember, when you are naming, you are looking for the carbon. You are naming, remember, actually you are naming from left to right, and also you are naming from right to left. But now the question is, which one do you take at any given point? The key in IUPAC naming is to look at the word list number of carbons from the functional group. Okay, so is the list number of carbons from the functional group or from the branch? I'll explain that, or from the branch, or let me just leave that. But now in this scenario, we're looking at the list number of carbons from the functional group. Now look at this now. If I can name this compound going from right to left, this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5. So the most interesting side is for me to ask, where is the carbon, double bond carbon having the list number? If I'm moving from left to right, look at it. The carbon, double bond carbon is 3 and 4. This is this direction. But if I'm moving from right to left, the carbon, double bond carbon is 2 and 3. So you can see that 3 and 4, if I add, actually 3 plus 4 will give me 7, but here 2 plus 3 will give me 5. So this, the list one is from what? From right to left. I repeat again, you look at the what? At the functional group, and the functional group here is the carbon, double bond, carbon. It is the one that tells me from which side is the list numbering. So when you have done that, if I'm moving from left to right, you can see that this carbon, double bond carbon is in carbon number 3 and carbon number 4. That's where the double bond is. But now I cannot take this one because it is the highest numbering. I'm looking for the least numbering, the smallest numbering, and you can see that it is this version whereby I take carbon 2 and carbon 3. So which means when I'm numbering, it will be carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. Alright, and then from here I can now give the name. The parent chain here is what? The parent 5 carbon is pent. remember, from pentane, that is the alkane version of it, that's 5 carbon. But now, since we're dealing with alkenes, we don't have A and E, we have pentene. That's alkenes, is pentene. But now, from pentene, or you can say pent as the longest chain, it's not complete. You need to tell us where is the carbon, double bond carbon. We are saying it is in carbon, the list number there, it's in carbon number 2. Don't say 2, 3. That's from the first carbon that is a double bond, is carbon number 2. So then you're going to write it as, they used to accept this. Let me show you. They used to accept it to say, in carbon number 2 hyphen, there is pentene. They will still accept it, but that's not the actual way of writing. The one that you need, the one that is correct, you can write it like this. If you want to bring us the proper answer, you're going to say it's pent, then it's pentene. See that? There is the name pentene from here. But now you are telling us that in carbon hyphen, in carbon 2, there is pentene. So it's pent 2 in, meaning in carbon number 2, that's where I'll find pentene. As I said, it's fine to say in carbon number 2 there is pentene. So 2, remember the number and the letter is a hyphen. It's correct, but this is in a way an uncomfortable answer now, but it's still a correct answer. They won't make you wrong. But the right one, where you are feeling confident with your answer, is saying pent 2 in. Did you see what I said I did? So remember, guys, the first one is to identify, have your functional group. In this case, we're looking at alkenes. So look at the carbon which has got the least numbering, the smallest number, and we say it is carbon 2. And then from there, you can now name the structure. Let's go to the next one. This is the next structure. If I can reduce this so that we can see the full structure. Look at this. We are supposed to give the IUPAC name of this compound, and it's a bit confusing. I prefer if I can draw maybe the condensed structure of this one. But now always remember which one is your functional group, and the functional group here is the carbon double bond carbon. It's the one that will determine the numbering. So you can move either straight, count the carbons, you can move up, count the carbons, you can move down, count the carbons, you can even move down, count the carbons. The main is to look at the one with the highest numbering. So if I can look at this, the highest numbering, because going down, if I go straight from here, I can choose go down, but there's 1, 2 more. Go up, it's 1. Even here, go down, it's 1. So I'll leave out, actually this one is even off and that one is off. The one that is possible is either I go down or I go straight. If I go straight, it's 1, 2, and if I go down, it's 1, 2. So I can make this the branch because it's the same thing, and I will make that the other branch. And if I continue, remember I'm moving straight, this other one also is another branch. So if you look at it, I've got a methyl here. Even here I've got a methyl, that's the CH3, if you can check it, methyl. And then here is not, is 2 of them, is ethyl. See that? And then the straight chain. Now let's look at this. If I'm drawing this as a condensed structure, I've got the first part, it's CH3, and then I've got CH2, and then I've got C, then I've got CH3, and then here I've got this long one, CH2, CH3, then here I've got the C with CH3, and then I have a double bond there, and then I've got the CH and CH3. Now let me count the carbons here. The number of carbons on the structure is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So it's 1, 2, 3, 4, 5, 6. That's correct. But look at the carbon double bond. If I name it from left, to right, you can see that it will give me the double bond in carbon 4 and 5. You see that? But if I name it from right to left, which I think already you can see that is the proper one, it will give me carbon 1, 2, 3, 4, 5, and 6. Look at the double bond. Instead of 4, 5, I'll take 2, 3. Why? I said you must look at the numbering, which will give you the carbon, double bond carbon, the smallest numbering. Or you can add between the two carbon double bond. You say 4 plus 5, I get 9. And then 2 plus 3, I get 5. So you take the smallest number. It will still always work. So you look at the one where the carbon double bond has the least numbering. And you can see here from left to right, I start from carbon 4. And from right to left, I start from carbon 2. So this is the right one. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So the right numbering is this direction. Why? Because the carbon double bond starts from carbon 2. Now, 6 carbons, what is the parent chain, the root chain? The parent for 6 carbons is what? It's hexene, because we're dealing with what? We're dealing with alkenes. Remember, from alkanes, it was hexane, but we're not dealing with hexane. For alkenes, it's hexene. That is just to give you your thinking process now. But from hexene, we're not done. Some they don't even write hexene, they write hex to say it's 6. But I am writing hexene intentionally to say this is an alkene. Okay, from hexene, I know that in carbon number 2, I have got what? I've got the double bond. Or I would have written hex hyphen 2 hyphen in, because you are cutting it there, and then you're putting hyphen 2 hyphen. You see that? So now moving on, it's not complete again. It's hex 2 in. Yes, it's fine, but I have what? I have branches. Look at the branches I'm having. I've got this branch, I've got that branch, and I've got this branch. Now, since we're already moving from what? From right to left, don't worry with the branches now. Don't worry. Just name them to say how are they appearing. Look at this. I've got in carbon number 3 a methyl. Remember, this is methyl. And then you say this is methyl. And then you say this is ethyl. So what starts is what? E before M. So let me write this, the actual name now. We are saying since ethyl is starting, we start on this one, which is in carbon number 4 hyphen. I've got ethyl. And then again in carbon hyphen, in carbon number what? Look at the methyls. It's carbon number 3 and 4. So I'll say hyphen 3, because there are 2 of them. I'll say comma 4. You don't say 3 methyl 4 methyl. No, you say 3 comma 4 hyphen, and then you say di methyl. Please don't forget, if you say di, it doesn't mean that we're saying D starts before E. Don't worry about the di part. We're looking at M. The methyl is the one that determines the alphabetical order, not the D. Just to say di, say that there are 2 of them. The actual name there is for methyl. So E starts before M. Don't consider the D there for the di. So it's 4 hyphen ethyl hyphen 3 comma 4 hyphen di methyl, and then hex, and then hyphen 2 in. You see that? That's the structure. This is how you name this compound. I know it looks a little bit complicated, but if you get the jinx of it with time, you're not going to start having some issues with that. Let's move on to name also this structure here. Look at this. Again, always follow the what? The highest numbering, the highest number, the lowest order of numbering, and look for the parent chain. So if I move straight here, you can see that I can take that as actually this is the longest chain, because the rest are branches. This is a branch, and this is a branch. You see that? So if I do a condensed structure here, what will I have? I have CH3, CH2, CH, double bond, C, CH3. This is what I'm having. So it's 1, 2, 3, 4, 5. So it's 1, 2, 3, 4, 5. Okay, and then after the double bond here, I've got a CH3, and then in here I've got a CH3. All right. If I did that, I think I did that right. Remember, always maintain the chemistry of carbon, a maximum of 4 bonds and a minimum of 4 bonds. And then, as I said, these are my branches, and these are my branches. If I look at this carbon double bond, you can see that moving from right to left will make this carbon 1, 2, 3, 4, and 5. But if I choose the other one where I'm naming from left to right, look at this, it's 1, 2, 3, 4, 5. Look at the double bond, 3 and 4 and 2 and 3. So the right one is from what? This direction. It's from right to left. I think you've already seen that. It's got what? Carbon number 2, but the other one has got carbon number 3. So we leave that one out. So how do you name it? Ask yourself the longest chain. It's 5 carbons. So it comes from pentane, which is now pentene, right? But we're not done. Where is the carbon double bond carbon? It's in 2-pentene, but as I said, you don't say 2-pentene. That's when you write now pentene. See that? Then say hyphen 2-pentene, and then you go back and say where is the branches. It's in carbon number what? Remember, we are looking from right to left. It's in carbon number 2. So you're going to say in carbon number 2 there is a methyl, comma, in carbon number 2 there is another methyl. So this is in carbon 2 and that is in carbon 2. So you say 2, 2 hyphen methyl, not actually methyl. Since there are 2, we say what? Di. So it's dimethyl. So it's 2, 2 dimethyl pent-2-ene. You see that? 2, 2. I was trying to fit it in here because already I have written that pent-2-ene. So let me say it's 2, 2 after number 2, 2 hyphen dimethyl. There mustn't be space there. 2, 2 dimethyl pent-2-ene. So that's the name of that. Moving on, let's look at this structure here. What is the name of the structure? Guys, always follow your functional group. There is a double bond here. You see, it's already telling me that I must follow that route. Now look, I'm going to draw the condensed structure of this so that you can see how I follow that. So let's start here. It's CH3, and then it's CH, and then down there it's CH3. You'll see how easy it is when you do it like this. And then I've got C double bond CH2 here, and then I've got CH2 and CH3. Look at this. So this is what I have. It's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then going up that. Look at this. My main guy here is this guy. So if this guy is my main guy, it means I can either go this route or I can go this route, because I must follow this guy. Are you with me? Because he is the main guy. So in a way, oh yes, I have to follow. That is the guy that I must follow, because it is the what? It is the main chain. It is the main parent chain. But now if you look at the one, when I'm using this part to say the numbering is 1, 2, 3, and 4. And if I number the other side, it's 1, 2, 3, and 4. Now if I take from right to left, Let me draw it now from right to left. Look at what I'm going to be having. I will make this the main line as CH2 double bond CH2 and then CH3. So I've made that the front line. Then going down, I think here, like that, it is CH3. I mean CH2. It's CH3, and then here it's CH3. Look what I just did. What I just did is I twisted this part whereby let me take it. I took this guy here and put it in here, like I stretched it. I'm trying to demonstrate. It's like I stretched this guy here. Let me use a red one. I took this guy, I stretched it this side and then rotated it in a way. I'm rotating it, and then this guy was forced to come here and it became like this structure in a way. At the same time, I can draw this structure as, look at it, I can draw this structure as this direction where it will be CH3 and then CH, have that as CH3, and then after that I've got this, so it's CH3 CH and then C double bond, you see, CH2. I'm making it flat like this. The CH2 has gone down, and then this one here will become CH2 CH3. I hope this you can picture how I've done. This becomes now a branch, and this becomes a branch. Look, now I just took this guy into the straight line here. That's what I just did. It's now 1 2 3 4. So it's carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So this becomes a branch and this becomes a branch. So what is the name now when I'm naming the structure? Remember, the longest chain is what, 4 carbons, but now look at the numbering 1 2 3 4. I'm not going to use that because carbon double bond is in carbon 3, but I'll use 1 2 3 4. You always want your carbon double bond to have the least number, which is carbon number 1, right? So now 4 carbons means what? You are dealing with what? You're dealing with butene. Okay, and as I told you, butene, where is the carbon? In carbon number 1, but we don't write like that. We don't say 1 butene, as I say. You say but, and then hyphen 1 in. That's the first part. Then the second part that you are aware, if I take this name down here, take this name. The second part that you are aware with but 1 in is to look at the branches. See, as I said, this is the methyl and this is the ethyl. Sorry, the other way around. This is the ethyl and this is the methyl. This is methyl, it's 1 carbon, and the top one is what? The top one is actually ethyl, not, it's 2 carbons. Okay, so you start with ethyl. So what is ethyl? Ethyl is in carbon number what? Carbon number, the numbering is that, not 3, but carbon number 2. So it's 2 ethyl, right? And then in carbon number 3 hyphen methyl stretch it, and then let me write it right. 3 hyphen methyl. It must be one word, but 1 in. I think that this must be closer, mustn't be space. So it's 2 ethyl, 3 methyl, but 1 in. Then it becomes the name of that structure. So guys, I hope this is kind of making sense as we are looking at this IUPAC naming. Now look at the structure. My time is almost up, but let me quickly try to look at the structure. Look at the structure. Okay, now always consider your functional group, and this is the functional group. It forces me to do my numbering on this group. It doesn't matter if there is a longer chain, but I must follow this guy and identify the longest chain from that functional group. So I cannot for example, I cannot do this and say the longest chain I go like this. I can't. You understand? Whenever I'm going, I must pass via the functional group. So I can go like this, yes, it's allowed, or I can go straight and do that. Are you with me? So if I go straight, since there are two carbons, after this one there's 2 and 2, it will be the same. This becomes my ethyl group, and then this one becomes my methyl, and then this one also becomes my methyl. So these are what? These are simple my branches. Now if I number, look at the numbering where the carbon double bond carbon is. Remember, I'm going straight. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. This is very interesting. I'm going to show you how it goes about. Now this is from this direction. Now let's go in this direction. I'll use a different one now. If I'm going this direction, I have got carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So I'm going to write the names now. What is the first name? The one in red. Let's identify. So 6 carbon is hexene, and hex is in carbon number 3. See the double bond there? Carbon number 3. So I will have hex 3 in. So far so good. That one is not a problem. But now look at the branches of this structure. We have got what? On the branches, I have got starting with ethyl, I have got 4 ethyl, and I wrote it wrong there because number 4 follows with what? Hyphen. So it's number 4, there it is. I've got ethyl, and then hyphen. I've got in carbon number 2 and carbon number 3, I've got 2 branches methyl. So it's 2, 3 hyphen dimethyl and what? Hex 3 in. Just for my space, I know it's a bit tight there. Hexene, hex 3 in, but it's this name, hex 3 in. All right. So now I'm going to write it now this direction. Let's follow this direction. What do I have? In this direction, I'm going to have on the ethyl, look, it's carbon number 3. So it's going to be 3 ethyl, and then I put a hyphen. Now what is going to be my methyl group is going to be in carbon number 4 and 5. So 4, 5 dimethyl hex 3 in. Now the guy who is coming in the alphabetical order, remember hex 3 in, it doesn't matter whether you're moving from left to right or right to left, it's that center. But now the guy who's determining which direction I must take is this guy, the ethyl. Why? Because ethyl starts before what? Before methyl. E starts before M. So it forces me to take the smallest number of E. So this one, the number of E is in carbon 4, but here is in carbon 3. So the name that becomes correct, therefore, is that one. It's 3 ethyl, 4, 5 dimethyl hexene. Why? Because ethyl is the guy who determines the direction that I must take, because it starts before M. Alright, so that is that part there. And Just to wrap up this one, I know it took more time. It says draw the structure of the following compounds. Number 1, pent-2-ene. Pent-2-ene, how will you draw that structure? Pentene is 5. 1, 2, 3, 4, 5. That's pentene. Pent is 5. Alright, if I can expand that. Pent means what? Pent means 5. You agree with me? Yes. And then it says in couple number 2, that's where the double bond is. So you can name it slowly and say this is carbon on top, this is carbon 1, this is carbon 2, this is carbon 3, 4, and 5. So it's carbon 2, that's where you put the double bond there. So it starts from carbon 2, not 1 and 2, it will be 2 and 3, because it says where carbon, you start with the least number, remember. So in this carbon 2, that's where the double bond is. So after that, we are done. Remove this numbering, spin 2 in, and then you start putting your hydrogen. This is the structure. This. Then don't forget to maintain the right number of what? Of hydrogens of this structure. Alright. This then becomes pent-2-ene. Alright. Okay, I was now underlining the wrong pent-2-ene. Anything? Any questions? That's that, pent-2-ene. And then the other one is what? Let me erase that. It says, or let me just draw it in another part. Let's leave it like that. Maybe you want to keep looking at it. The other one says we must draw the structure of what? 3-methyl-hex-2-ene. Hex is the parent chain. Hex is what? 6. So if hex is 6, so it's gonna be 1, 2, 3, 4, 5, 6. And whenever you're drawing your own structure, it's better to go this direction, you know, so that you don't confuse yourself. But it says hex 2, so it's carbon number 1, 2 there. Carbon 1, carbon 2, I must have the double bond. I see that. So it's hex 2 in. So hex 2 in, you know that that's an alkene. Alkene. And then in carbon number 3, there is methyl. So 1, 2, 3. Here, there is a methyl, C, H, H, and H. It's a methyl. That's the CH3. And then what else? Nothing. Then you put your hydrogens. Like this. Hydrogen. Now, be careful now on this, on the fourth hydrogen. 1, 2 on the third hydrogen. So remember, it's got this bond, this bond, this bond, this bond. Don't be tempted now to put that. It will have 5 bonds, so it's gonna be wrong. They're gonna penalize you there. So be careful with your hydrogens. Always be careful. Count the number of hydrogens, and actually count the number of bonds. There must always be 4 bonds, not 5. 4 bonds. So that becomes the structure. I think that. And then the other one there, it's 2, 3, 4 trimethyl pent 1 in. Alright, let me do that one. Pent is what? It's 5. So it's 1, 2, 3, 4, 5. Pent 1. Let's start there in carbon number 1. Alright. So at that moment, the hydrogen is there. The hydrogen is there. Then it says in carbon number 2, here, there will be a what? There will be a 2, 3. Let me do it down actually. In carbon number 2, down here, there is a what? A CH. It's carbon, hydrogen, hydrogen, methyl. There is the methyl. And then in carbon number 3, there is carbon number 3. Again, there is another methyl. It's better to keep opposing it so that you can have enough space. The aim is to at least make the structure clear. Okay. So there is a hydrogen still there. And then in carbon number 4, there is another one here. I think that. And then after that, you've got that 1, 2, and 3. But this is not complete. I put also another hydrogen there. Always check the number of hydrogens. The other ones 1, 2, 3, 4. Then that becomes 2, 3, 4 trimethyl pent 1 in. Then you get this structure. I hope these are making sense, guys, as you are doing your what? Your revision. I hope these are making sense. Now, in the next lesson. This is the end of the lesson. I know it was longer than anticipated, but just hang in there. The aim is to make these lessons 24 minutes. Now the next structure, we're going to look at alkynes. I don't want you to miss out on this lesson so that you can be able to catch it as it goes. So make sure that you sit and listen to alkynes so that it can give you now a better understanding of this. We've come to the end of our lesson. Thank you.